LeetCode 124, binary tree maximum path sum. So this problem gives us a binary tree, and our job is to return the maximum number from a path. So for this example, the longest path would be from 2 to 1 and 1 to 3, so the total will be 2 plus 1 and then plus 3, which will give us 6. Right? And for something like this, we have to go the path where the sum is the highest. So in this case, the highest sum is 15 to 20 to 7, which will give us 42. Even though there is a longer path here, right? But if you add them up, this negative 10 will, the total will be actually smaller than this total. Right? So we have to find the path that gives us the maximum number. Okay, and you can't like you cannot do something like 9 and then go to 15 and after that come back to 20 again, right? So this isn't, you cannot visit a node twice, you can only visit it once per path, and that's about it. So my method of doing this is to use a DFS method, and the way I do it is I count from, let's say, from uh, from the root, for example, what's the highest number on the left, which in this case would be 9, and the highest number on the right. But in this case, since this 20 is another subtree, so we have to recurse and go through here. So in this case, the higher number is 15, and it's 7 here. So we have both 15 and 7. And next thing I want to know is if I were to combine all these number, what is the total? So in this case, the total will be 42. But let's say if this total is okay, never mind that. But this total is 42. So now, so if let's say this were to be like, I don't know, 110, for example, then what I will need to do is, using this 20, I'll have to add the highest number that is the left or the right. So in this case, the highest number is 15. So 15 plus 20, this is actually 35. So we're comparing 35 with 9 here, and obviously this 110 will take the 35. So this will give us 145 as the final example. Right, so that's the gist of it. So let's walk through how the code actually works. So in the starting function, the max path sum function, I have a max path which I initialize as the most minimum. So this is what we are actually going to return. You can see here, and in my depth first search, I'm referencing the root. I'm referencing the max path, and here I'm putting in the root. Right. So I'm going to use this example on the left. So right now our root is at -10, and our max path I'll put it at the top because it will never it's reference, so I don't need to recreate it. In this case, max path, let's say, is -9. Okay, obviously this is not int min, but this is a good small number to start with. So if root is equal to null, in this case it's not, it's -10, so we go to the left. Right. So left is equals to a max of the left and 0. Right. So I'm just gonna put 0 here first. And then we are going to the left. So I'm going to open a bracket here, which means that this is a recursion. So again, root is now, we're going to left, right? So root is now 9. 9, so it's not 9. Okay, it's not now, and we go to left again. So left is equals to max of 0 and to the left again. Right. So go to the left, and now since this left since this left is null, so uh, so this root is actually 0, right? It's null, so it will return 0, meaning that this left is 0. So the maximum of two zeros are 0, 0. And let's try the right, which in this case it's the same thing, right? Since it's null, so this will be 0 as well. Okay. So now we update our max path in case if these two were to be numbers, something like this, we have to add all three of them up together to see whether they are higher than our max path. But currently, if we were to compare, right, so the max of -99 with root's value, which is 9, plus 0 plus 0, right, 2 zeros here, so our max path will need to be updated. So now max path is 9. Okay. Once that is done, I will return the value over here. In this case, it will be 9 plus the maximum number of both, or no, the maximum number of either the left or the right. So if you use this as an example, the maximum number will be 15. So I'll return 20 plus 15. So this will be 35. Then we can refer back here. But in this case, since both of it is null, so it will just be 9, right, plus 0. Okay, so once I returned 9, in this case if we see here, this recursion will end, and here I'll get 9. Okay, then we move to the right. Okay, so left right now the maximum of of 0 and 9 is 9, and now we go to right. So right equals to max DFS, maximum of 0, and the right. Okay, so the root now is 20, and then we go to left again. So left is equals to max of 0, and left again, so it's over here, so it's 15 now. Okay, it's 15. Then we go to left again, but in this case left is now null, it's now null, right? Both left and right are null, so left is 0, right is 0. So we check our max path. Okay, one thing I forgot to mention is that a single node can be a single path if the number is so ridiculously big that uh, basically all the other numbers are negatives, and if this one is the only positive one, then this will be the biggest number, therefore it being the only path that is the maximum path. So that's why we have to calculate the max path as well, even though it's only a single node, right? Which is the same thing as it over here, yeah, just that I forgot to mention. Anyways, let's calculate max path equals to max of currently 9, and then root, which is 15, plus 0, which we get 15. So now, right now, max path will be updated to 15. Okay, and then I'm going to return the root val plus, in this case is 0. So root's value is 15. So this left is now going to be 15. And the maximum of 0 and 15 is 15. Okay, let's move to the right. This is going to be the same thing. Okay, now I go to the right side, is 7. Then move to the left. The left of it is a null, and so is the right. So left is 0, right is 0, and then max path is the max of 15, and for the right root is 7 here, max 7. 15 and 7 plus 0 plus 0, right, which is also 7. Okay, maximum is still 15, so we don't really need to update it. And then we return 7 plus 0, right? So this right will now be 7. Okay, which in this case the maximum of both these will be 7. Okay, now we're back at 20. We're back at 20. You can see here we're back at 20. And then we calculate our max path again. So max path is equals to the maximum of 15. And then root val is 20 plus left plus right. So 15 and 7. 15 and 7. So this one will give us 22. This is 42. And the maximum between these two numbers is 42. So our max path will be updated. And then I return the root value, which is in this case is 20. Right, it's 20 plus the bigger number among these two, which in this case is 15. So this will be 35. Maximum number with these two is 35. Okay, then we have something like this. Then we just need to calculate the max path again. So max path, maximum of 42. The root is unfortunately negative 10 plus 9 plus 35, right? So we simplify this. 35 plus 9, this is 34, which is still smaller than 42. So max path is not updated, it is still at 42. And then we return, but it doesn't matter because our DFS does not use that return value. So in that case, our max path is 42, which is the answer. Right? Let's erase, right? Which is the answer over here. Okay, so that's how we got 42, which is the max path sum of this binary tree. Alright, hopefully my explanation helped. That's all I have to show. Thanks.